At 22:30 local time on July 2, 2025, a Ukrainian Vilkha-M crew knew Pokrovsk was gearing up to fire at a Russian ammunition depot when suddenly they detected electromagnetic emissions from a Russian Zoopark M1 counter-battery radar 38 kilometers away. This was about to change a routine strike into a fight for survival. The radar operator's first indication of trouble came when his passive receivers lit up with the distinctive frequency signature of the Zoopark's search pattern. This Russian system can detect outgoing artillery at a range of 23 kilometers and calculate launch positions within 30 seconds. The crew had fired a harassment barrage 15 minutes earlier. Now, Russian MLRS crews are hunting them. Based on standard response times, they had exactly 6 minutes before BM-30 Smerch rockets would arrive at their position. Their 12-tube Vilkha-M launcher sat loaded with 4 missiles targeted at the Hartzik ammunition depot. The crew chief began emergency launch procedures while his gunner frantically worked to upload GPS coordinates. Each Vilkha-M required precise target data loaded through a hardened military tablet that communicated with the missile's guidance system via encrypted data link. This process normally took 3 minutes. They had to do it in 90 seconds. The Vilkha-M you see here represents Ukraine's most advanced indigenous rocket system. Developed by the Kiev Design Bureau, each missile weighs 800 kilograms and carries a 170-kilogram warhead capable of penetrating reinforced concrete. The guidance package incorporates GPS, GLONASS, which is Russia's own version of GPS that provides positioning signals just like GPS does, and inertial navigation systems. All of these systems combined provide a 10 to 30 meter accuracy at maximum range. But uploading coordinates while Russian radar painted their position added lethal complexity to an already dangerous process. At 22:32, Russian jamming intensified across all GPS frequencies. The tablet screen flickered as it lost satellite lock, forcing the gunner to switch to manual input mode. Without GPS verification, he had to trust that the pre-surveyed coordinates were accurate to within 5 meters. Any error would mean missing the target after revealing their position. Meanwhile, thermal sensors detected heat plumes 32 kilometers northeast. Smerch launchers had already fired. The loader slammed the blast door shut at 22:33 while scouting distance estimates. A Smerch rocket travels at 1,200 meters per second, meaning impact in approximately 4 minutes. The Vilkha-M's automatic loading system could prepare 1 missile every 20 seconds, but they needed to fire all 4 before displacement. Standard doctrine required a 45-second interval between launches to prevent thermal damage. They had 30. At 22:34, the first Vilkha-M roared from its tube, the launch signature immediately detected by every radar within 50 kilometers. The crew didn't wait to observe the trajectory. The gunner was already authorizing the second launch while the driver started the 8x8 transporter's engine. Ukrainian doctrine demanded displacement within 90 seconds of first launch, but completing the fire mission took priority. The second missile launched at 22:34 and 30 seconds. Its exhaust plume created a 40-meter thermal column visible to Russian infrared sensors. The Zoopark 1M had already calculated its position to within 50 meters and transmitted coordinates to multiple fire units. The crew chief could now hear the incoming Smerch rockets, a distinctive whistle that meant 30 seconds to impact. Third missile away at 22:35. The blast overpressure shattered windows in abandoned buildings 200 meters away. The launcher's thermal coating was already showing stress fractures from the rapid-fire sequence. One more shot, then they had to move. The driver revved the engine to 2,200 RPM, ready to accelerate the moment the final missile cleared. 30 seconds later, the fourth Vilkha-M launched just as the first Smerch rocket impacted 400 meters north of their position. The explosion sent shrapnel overhead as the crew floored it, the 30-ton vehicle lurching forward while rockets bracketed their former position. They've revealed themselves to every Russian unit within 100 kilometers. But 4 precision missiles were now streaking toward Hartzik at 1,100 meters per second. At 22:40 local time, the lead Vilkha-M rocket descended through 8,000 meters altitude as it approached the forward edge of Russian air defenses. The missile's onboard computer processed navigation updates 50 times per second while analyzing jamming signals attempting to corrupt its GPS receivers. In about a minute, it would either deliver its warhead or become another statistic in the electronic warfare battle over Donbass. The missile's triple redundant guidance system immediately detected degraded GPS signals as it crossed into Russian-controlled airspace. Signal-to-noise ratios dropped below acceptable thresholds, forcing the guidance computer to switch to GLONASS backup. But Russian forces were jamming their own navigation system too, creating an electromagnetic dead zone designed to defeat precision weapons. Within 500 milliseconds, the Vilkha-M defaulted to pure inertial navigation, its fiber optic gyroscopes maintaining course accuracy of 0.2 degrees per hour. Meanwhile, 28 kilometers ahead, a Tor M2 Air Defense System's 9A331 combat vehicle detected the incoming rocket on its surveillance radar. The system operator watched his scope as the target descended through 6,000 meters at 1,100 meters per second, well within engagement parameters. The Tor's fire control radar began tracking, its phased array antenna focusing 600 kilowatts of power on the Vilkha-M's radar cross-section. Lock-on achieved at 22:41 hours and 15 seconds. The Tor M2 represents Russia's most capable point defense system against precision munitions. Its 9 M338 missiles can engage targets from a range of 1 kilometer to 15 kilometers at altitudes between 10 meters and 10,000 meters. The system's reaction time from dedication to launch is 5 to 7 seconds, with missiles accelerating to Mach 2.8 within 2 seconds of leaving the vertical launch tubes. Against a ballistic target following a predictable path, it should be a guaranteed hit. But the Vilkha-M wasn't flying predictably. At 22:42 hours, its guidance system initiated a program maneuver, banking 15 degrees left while maintaining a descent angle. This minor course correction moved it outside of the Tor's pre-calculated intercept zone, forcing the fire control computer to generate a new solution. The operator authorized automatic engagement anyway, and 2 9 M338 missiles erupted from their launch tubes 30 seconds later. The first interceptor climbed toward the calculated impact point, its radio command guidance system receiving steering updates from the ground station. But the Vilkha-M's designers had studied Russian air defense tactics. At 22:42, the rocket performed another pre-programmed jink, this time 20 degrees right with a slight pitch adjustment. The maneuver added only 300 meters to its flight path, but completely invalidated the Tor's firing solution. Realizing the first missiles would miss, the Tor operator switched to manual tracking mode. His screen showed the target now at 3,000 meters altitude, 18 kilometers downrange, with impact in less than 60 seconds. He fired 2 more missiles while alerting adjacent air defense units. A Panzer S-1 system 12 kilometers east acknowledged and began searching its sector. The second pair of Tor missiles performed better, their proximity fuses detonating within 50 meters of the Vilkha-M. Shrapnel peppered the rocket's aluminum skin but failed to penetrate the warhead casing or damage critical guidance components. The near miss did affect the trajectory. Onboard accelerometers detected a 2-degree deviation, which the flight computer immediately corrected. As the lead missile descended through 1,500 meters, the second Vilkha-M entered the engagement zone 30 seconds behind. The Tor crew, focused on the lead target, didn't expect it until 22:43. They had 4 missiles remaining and 2 targets approaching. Standard doctrine prioritized the closest threat, but engaging multiple high-speed targets simultaneously exceeded the system's real-world capabilities. The Panzer S-1 system tried to help, but faced its own problems. The Vilkha-Ms were approaching from just on the edge of their blind spot, requiring the turret to traverse 140 degrees while calculating a firing solution. By the time its 5.7E6 missiles were ready, the lead rocket had descended below 500 meters, entering the terrain masking zone that made terminal interception nearly impossible. Unless they did something in the next minute, these Vilkha missiles would be unstoppable. At 22:49 local time, the lead Vilkha-M rocket entered its terminal phase 8 kilometers from the Karsk ammunition depot. 4 separate Russian air defense systems converged their sensors on the incoming threat, creating overlapping fields of radar energy that painted it like a beacon. The next 45 seconds would determine whether months of Ukrainian intelligence work would pay off or vanish in a failed interception. The Tor M2 crew had one chance left. His radar indicated that the missile was following the terrain at an altitude of 400 meters, using a small ridgeline to mask its approach. In 15 seconds, it would clear the ridge and dive toward the target. He preset his remaining missiles for the calculated pop-up point and waited. 3 kilometers south, a Panzer S-1 finally joined the engagement. This modern system carried 12 57E6 missiles with radio command guidance effective out to 20 kilometers. The crew had been tracking the Vilkha-M since it descended below 1,000 meters, but couldn't achieve a solid lock through the ground clutter. Their phased array radar cycled through different frequencies, trying to burn through the interference that was caused by other interferences. No luck. The depot's last line of defense was this ZSU-23-4 Shilka positioned on the facility's northern perimeter. Its 4 23mm autocannons could pump out 3,400 rounds per minute, creating a wall of lead designed to shred low-flying aircraft and missiles. The gunner traversed his turret toward the anticipated approach vector, the radar-guided fire control system struggling to differentiate the incoming missile from background returns. At a 300 meters per second closure rate, he'd have perhaps 3 seconds to engage. At 22:49, the Vilkha-M crested the ridge exactly where the Tor operator predicted. Both remaining 9 M338 missiles launched instantly, their rocket motors illuminating the darkness as they accelerated toward the intercept point. The missile's altitude was now 380 meters and dropping, following a ballistic trajectory that would impact the depot in 12 seconds. The Tor missiles had 8 seconds to intercept. But the second Vilkha-M chose that moment to appear, cresting the same ridge 2 kilometers north. The Panzer crew, startled by the new threat, split their engagement, firing 3 57E6 missiles at each target. This violated doctrine requiring concentrated fire, but panic overrode training. Their missiles, command-guided and capable of Mach 3, would need 8 seconds to reach the targets. But splitting fire between 2 maneuvering threats drastically reduced hit probability. The lead Vilkha-M's warhead was now armed as it passed through an altitude of 200 meters. Impact fusing circuits activated while the radar altimeter provided final height corrections. Below, Russian ammunition handlers scrambled for cover, abandoning forklifts loaded with 122mm Grad rockets. They'd been alerted 30 seconds earlier, but moving thousands of tons of ordnance required hours, not minutes. At 22:50, the Tor's missiles passed within 30 meters of the lead Vilkha-M, close enough for proximity fusing, but the target's speed and angle exceeded parameters. Both interceptors detonated harmlessly behind the rocket as it entered its terminal dive. The Shilka opened fire at 600 meters range, its quadruple cannons filling the air with tracer rounds. The gunner held the trigger for 2.5 seconds, expending 280 rounds in a futile attempt to create an impenetrable barrier. The third Vilkha-M appeared 20 seconds later, approaching from the east where air defense coverage was thinnest. Across the depot, sirens wailed as personnel ran for bunkers that wouldn't save them from what was coming next. At 22:49 and 10 seconds, the lead missile's radar proximity fuse detected the warehouse roof 5 meters below. The warhead detonated on contact, 170 kilograms of high explosive, creating an overpressure wave that collapsed the building's eastern wall instantly. But this was just the primer. Inside were thousands of tons of Russian ammunition about to begin the deadliest fireworks show in Donbass. At 22:49 and 15 seconds local time, the initial explosion from the first Vilkha-M warhead reached the nearest ammunition stack. Pallets of 152mm artillery shells stacked 4 meters high. The blast wave compressed the air between wooden crates, creating temperatures exceeding 3,000 degrees Celsius. Propellant charges designed to withstand rough handling couldn't survive this terminal assault. Within 300 milliseconds, the first secondary explosion erupted. The second Vilkha-M impacted the northern storage building 30 seconds later, its warhead penetrating the reinforced roof before detonating among crates of BM-21 Grad rockets. Each 122mm rocket contained 18.4 kilograms of solid fuel that burned at 2200 degrees when ignited properly, or exploded violently when subjected to shock detonation. The initial blast set off 6 rockets simultaneously, their combined explosion lifting the 15-ton roof structure completely off its supports. The third Vilkha-M struck the western warehouse at 22:50 and 20 seconds, targeting pallets of 9M22U Grad rockets equipped with advanced warheads. These weapons contained not just high explosives, but sub-munition dispensers designed to scatter anti-personnel mines. The heat and overpressure caused the sub-munitions to detonate inside their casings, creating a devastating secondary blast that collapsed the building's structural supports. Burning rocket fuel sprayed across the compound like napalm. At 22:51, the fires reached the depot's prize stockpile, S-300 surface-to-air missiles in storage configuration. Each 5 B-55 missile contained 133 kilograms of high explosive plus solid rocket fuel in its sustainer motor. The blast wave shattered windows in Kharkiv city center 3 kilometers away. The fourth and final Vilkha-M arrived at 22:52, but its target no longer existed in any meaningful sense. Programmed for the eastern warehouse, it instead impacted a burning hellscape of twisted metal and exploding ordnance. Its warhead added to the conflagration, but by now the chain reaction had become self-sustaining. Solid rocket motors launched themselves horizontally, spinning wildly before detonating against perimeter fencing or other buildings. Russian firefighting teams 2 kilometers away could only watch helplessly as temperatures exceeded 1800 degrees. At 22:55, an underground bunker containing 300mm Smerch rockets detonated, creating a 40-meter crater and distinctive mushroom cloud that social media captured from multiple angles. By 23:10, 4 massive fires glowed where warehouses once stood. Conservative estimates on the damage placed it at 3,000 tons of ammunition destroyed. In battlefield impact, that meant 3 weeks of Russian artillery suddenly vaporized. Within hours, panicked orders dispersed remaining stockpiles across multiple facilities, reducing efficiency and increasing vulnerabilities. Exactly what Ukrainian planners intended. Bye for now.